Hi guys, today I will teach you about structural isomerism. In structural isomerism, we have three types: position, functional group, and chain isomerism. So let's actually look into the position isomerism. Now for the first example, I'm going to show you with this example, carbon double bond, okay, with another three carbon, which is going to be, this is going to be put one in. Okay, put one in, you can look at position number one, and we have, okay, in this position isomerism, the double bond, the alkene, okay, the double bond can change the position to position number two. So if let's say I put it into the position number two, the space of two, yeah, so that is going to be named as put two in. So we can see the difference now. You have put one in and put two in, and they are isomer, and this is going to be positional isomer. And if let's say we have a halogenal alkane, for example, bromobutane over here, the position of the bromine is going to be attached, the bromine atom is going to be attached at carbon number one. So therefore, we name this as one bromobutane. But this position of the bromine, we can change the position. Let's say if I put it at position number two, and I am going to have two bromobutane. So I'm going to actually use it over here, two bromobutane. So you can see one bromobutane and two bromobutane, they are isomer to one another. And this is going to be what we call as position isomer. And for the next one, it's going to be functional group isomer. Okay, so let's actually look at this molecular formula, C3H8O. So I will think, okay, I have three carbon. So I'll draw three carbon, and then I have one O. I can think of alcohol. Okay, alcohol has one oxygen atom. Okay, I draw the formula for propanol over here. So when I draw and I count, yeah, it matches. Okay, C3H8O. But okay, there is another isomer, which is, we call it as a functional group isomer, where it is not alcohol. So if I put the three carbon, okay, over here, but between one of the carbon, I'm going to put the O instead of OH. Okay, and I will have this structure. And when I count, okay, the number of hydrogen, I will have the number of hydrogen, which is going to be also going to be 8. So I will have the same molecular formula as earlier one. So now having the same molecular formula, but you are going to have different functional group, which is going to be, this one is going to be alcohol. The functional group is hydroxyl group. But now we have ether, okay, which is going to be, there are two different functional groups. Therefore, this is going to be functional group isomerism. We can have another example for this. Okay, let's say if we are looking into C3H6O, C3H6O, we can actually draw a aldehyde, an aldehyde. So an aldehyde with three carbon, and I will actually draw, because aldehyde will have this formula. And when I draw, okay, I will have all these matches to this molecular formula. But this aldehyde, okay, I can draw a three carbon, and I, instead of drawing aldehyde, I can also draw a ketone. So now, okay, when I draw the ketone and I compare, now they are the same, having the same molecular formula, but they are going to have different functional group. So this is going to be aldehyde, and this is going to be ketone. So this is going to be, we can just say that, okay, having the same molecular formula, different structure in terms of functional group. So this is going to be a functional group isomer. So we can also have another example. So I have given you one example on alcohol and ether. Second example, I give you aldehyde and ketone. The third example is related to CnH2n, the general formula that we use for alkene. So we know, like, for example, 4 carbon alkene, so we have C4H8. If I draw, okay, a simple put one in, okay. So when I draw this, okay, I see, okay, this is going to be, we have an alkene. But I can also draw this in this form, which is going to be, I connect all the carbons together, and I will have a cyclic structure. This is a cyclic structure. So I call this as cyclobutane. Please take note that there is no double bond over here in this molecule. So here, this is going to be somehow an alkene, and this is going to be a cycloalkane. So alkene and cycloalkane, they have carbon double bond, and then this is only single bond. So therefore, okay, they are different. Okay, so this is also a functional group isomer. The last one is going to be for chain isomer. For example, if I have butane, so I draw butane is 4 carbons, I draw butane, all single bonds. I can actually have, okay, if I break this, okay, and form, okay, let's say this is going to be, when I break this, I'm going to have CH3. So this CH3, if I have only 3 carbon, okay, 3 carbon, and then this CH3, I put it in the middle. Okay, so make sure, okay, when you do chain isomer, you need to break and put it in the middle. Okay, so cannot put it at the side or at the end. Okay, so it must be somewhere in the middle. So in this case, if I want to name this, okay, this is going to be again like butane, but this is going to be a different molecule, which is going to be having the same molecular formula, okay, but the name is going to be different now. The longest carbon chain is going to be 3, so it's a propane. And at the position number 2, okay, you have methyl. You can actually choose to ignore the 2, but here I'll just simply put 2-methyl propane. Okay, and these 2 are chain isomer. So chain means we break and put it somewhere in the middle. So this is branching. Okay, so for pentane, another example for pentane. So if I have 5 carbon, I can have, okay, I break over here. I have 4 carbon, and the CH3 can come either here at this position or this position, but doesn't matter. They are still going to be the same. Okay, the name is still going to be the same. You flip the molecule, you are still going to get the same molecule, which is going to be butane. Okay, and position number 1, position number 2. So you still get 2-methyl butane, even though you put at this position or this position, doesn't matter. And we need to think about, okay, what happens is that the only we have only 2, okay, no, you can still actually break another one. Okay, so you have 3, which is going to be 3 carbon, and the CH3, one of the CH3 stay in the middle, another CH3, make sure it must be going to the middle, cannot to the end. So I put another CH3 over here. And if I look, can I break some more? No. Okay, there is no more space, okay, to actually put the CH3 anymore. Okay, because all the 4 bonds of that middle carbon has been used up. So this name, when we give name, this is propane, and this is position number 2. So it's 2,2 dimethyl propane. So that's it, guys. So you have 3 types of structural isomerism: position, functional group, and chain isomerism. Thank you, guys. See you. Bye.